All right, this is AP, AB, and BC Calculus. We're doing Unit 7, Section 3, which is sketching slope fields. So we're going to go ahead and get right into what a slope field is and how to sketch them. All right, so a slope field is a way of demonstrating the graphical behavior of a solution to a differential equation without actually knowing the solution. So you can see I've put two pictures of slope fields here, right? So this is one that's pretty complicated, and this is one that's much smaller, right? So what is a slope field? In a given set of points, usually 9 to 16 points if you're drawing something by hand. So down here at the bottom is an image that would probably be something you could be asked to do by hand, or a much larger set of data points if you're doing something on a computer or a calculator that allows you to do slope fields. So this top picture is something that would be on a computer program that would have an algorithm for doing slope fields, right? So you'll evaluate the differential equation dy dx at each of these point values, right? And since dy dx, right, is change in y over change in x, so right, so this is change in y over change in x, right, that represents slope. So each value of dy dx at a given point is a tiny, tiny little snippet of slope. It's a small line segment that shows the slope at that exact point. And you can see that a little bit easier down on this bottom diagram, right? So for instance, right here, right, at this point that I'll highlight in blue, right, that's the point negative 1, 1. And you can see that this little snippet of slope is a slope of negative 1, right? Because you can actually see that it would be down 1, right 1. That's a slope of negative 1. So for example, in this picture here, dy dx, if you had the equation, which you don't because I just gave you the picture, but if you evaluated dy dx at negative 1 comma 1, its value would be negative 1. And sure enough, this is a slope of negative 1, right? If I asked you, so let's just look at this point right here, right? So dy dx, whatever the equation is, which I didn't give you here, but if you had it, dy dx evaluated at the point negative 1, would it be a 0? Because you can see that's a slope that's level, right? That's a horizontal slope, a slope of 0. So basically, once you draw all those tiny snippets of slope, you end up with something that kind of looks like a river, right? And the tiny little small slope segments are like the current, right? And that's easier to see in this top picture right here, right? This kind of looks like it could be water that you're looking down at water patterns, right? Or it could be wind patterns in the air. So to anticipate the solution to a graph through a given point, you draw that point on the graph sort of like a leaf in the river, and then you follow the slopes, meaning the current of the river, to determine where the leaf floats. So just to show you an example, if we were to look at this diagram up here, let's say that I had a solution that started here at 0, 2, right? So let's say that this is my leaf, right? And I was asked to draw the solution that went through 0, 2. Well, I would follow the slopes down, and you see how they're pretty steep, and then they start to level out, right? Level out, and then, oh, look, they seem to turn up and become basically a line, right? A line that seems to be sort of a negative slope right here, right? And if I go back this way, the slopes seem to get steeper and steeper and steeper, and there's the curve that I'd get if I drew that curve that happens when I draw a leaf in at 0, 2. If instead, let's say that I asked you to draw a leaf down here, right? So let's say there was a different leaf that dropped in the river, and that leaf dropped in the river at 0, negative 2. Well, if I follow these slopes, you can see that they're pointing down and they're getting steeper and steeper. So this is going to go like this, right? As I follow this little line up, the lines get slightly less steep to the point where all of a sudden they're basically all in a straight line. And then that would be my rough approximation of the curve there, right? So each different point value that I have is going to yield a different possible solution curve. So why? Why would we do this? Well, differential equations are actually used in the real world to model a bunch of impossibly complicated systems. Systems with a large number of variables, something like weather, that might not be solvable, right? There's no way to solve the weather. That's why whenever they predict something like 20 inches of snow and then the next day you get 2 inches of snow, you kind of just have to say, oh, that's the way weather forecasts work, right? So we can't solve the system, but we can use the data that we have and we can use the differential equations we have to try and predict the system. So, you know, when you get those weather forecasts that are always changing, right? So let's say you have, so new data is added and it shifts the location of where the leaf is, right? So just like we saw in this last diagram, right? The difference between this data point and this data point made a very big difference in the direction that the curve traveled, right? So if at any given moment you're anticipating like let's say you have a certain temperature or a certain wind speed or a certain whatever, a certain pressure, right, that's measured, and that's making you think that the snowstorm is going to dump 20 to 24 inches of snow. But then the next day when there's a little bit more data, it looks like, oh, suddenly we're only getting 2 to 3 inches of snow and we definitely have to worry about that Miss Aguilera test tomorrow, right? So That's because as the data shifts, it drastically changes the outcome that we're expecting from the slope field that we have, right? So slope fields actually do pertain a lot to predicting things out in outer space, things with weather, things that have more variables than we can handle solving. While it's great in algebra and calc that often we're given equations that we can solve and that have a definitive answer, in the real world, math is applied in much more open-ended scenarios where you're not always going to have a solution, and rather using the math to try and inform educated opinions on what's going to happen, right? And that's a lot of what happens in higher level math. So let's go ahead and keep going with the math. So we're going to go ahead and draw a slope field at the 12 points indicated, and I know the numbers are really small here, but this grid is one unit per grid, right? So this is 0 and -1 and so on, right? So what I'm going to suggest, and you definitely don't have to do this, but especially with a larger slope field like this, it's not a terrible idea to list the points, right? It's a lot of points. 12 is a decent number of points. It's not a terrible idea to list the points and then find the slope in sort of a table, right? So what I'm going to do is I'm going to go ahead and list the point x comma y, right? And then I'm going to go ahead and find the slope. Oh, that's not great. All right, there we go. I'm going to find the slope, which is just x plus y at a given point. So when I do this, I have no good reason. I always start bottom left, and then I work up and up and up. I know that's counterintuitive. Maybe some people would work the way you read. For whatever reason, I always start with this point, and I work up like this. I don't have a good reason why. So the point I'm going to start with is -1, -1, right? The next point is -1, 0, -1, 1, and -1, 2. You really don't have to do this in the order I'm doing it. You just have to do it in an order so that you make sure you get all the points. The next set of points are those same points, but with an x-coordinate of 0, right? So 0, -1, 0, 0, 0, 1, and 0, 2, right? And I just color-coded so that I could clearly point out that there's 4 more points, so that whole row would be red, right? And then I'm going to make one more little row for myself where I list the x, y point, and then the slope is x plus y, right? And you don't have to do this work. You can certainly do it in your head, but if you do it in your head and you get it wrong, then you're going to be all surly, right? Because these are, I'll sort of walk you through how the AP would score slope field points in a second. All right, so those are my 12 points. So when I go to find my slope, right, it's just x plus y. So -1 plus -1 is going to give me a slope of -2, right? So we'll plot the slopes in a minute, right? So -1 plus 0 gives me -1, -1 plus 1 gives me 0, -1 plus 2 gives me 1, right? The next set of slopes, 0 plus -1 is -1, 0, 0 is a 0, 0 plus 1 is 1, and 0 plus 2 is 2. Again, this is a particular instance where you might not necessarily need to write it down because it's fairly simple. -1 plus 1 is a 0, 1 plus 0 is 1, 1 plus 1 is 2, and 1 plus 2 is 3. So now let's talk about how we're going to write these slopes, right? So you're just drawing tiny, tiny little short lines of slope, okay? So let's do the green ones first. So the first slope is a -2. So from here, I'm supposed to go down 2 and right 1. I just need a tiny snippet of slope that kind of points to that spot, right? The next slope is a -1, so I'm here and I go down 1, right 1. Well, that's going to point right there. And I want you to notice that my -1 slope is slightly flatter than my -2 slope. The next slope is 0, and that's important. And we're going to, I'm going to go ahead and put that, I'm going to put a little yellow line on that for a sec because that's important, and we'll talk about why in a second, okay? The next slope, right, is a slope of a +1, so that's either up 1, right 1, or if you don't have room to do that, you could go down 1, left 1, and it's going to look like this. And basically, it's the same slope that I had here, but pointing in the positive direction. Then my red slopes, right, so right here I have a slope of -1, which is down 1, right 1, so something like that, and you'll notice that this was also a slope of -1, so they should sort of line up, right? At 0, 0, my slope is 0, and I'm going to go ahead and highlight that again with that little yellow because I want to talk about that as being an important slope in a minute. The next slope is a slope of 1, so that's, I go here and I go up 1, right 1, so that's going to be here, and you'll notice that this slope up here was also 1, so they should look the same. And then up here I have a slope of 2, so that's up 2 and right. So I actually had to go off the screen from what you can see, so up 2 and right 1. If you can't see it, you might want to go down 2 and left 1, so I'm pointing to this spot right here. So I just go here, same idea. Okay, and then the last set of slopes, right? So 1, -1 is going to be 0. And again, I'm going to highlight that that's important. I'm going to put that little yellow spot on it just so we're clear that that's important. The next slope is a slope of 1, which we've seen twice. We saw it here and we saw it here. So you can basically just mirror that same slope, right? The next slope is a slope of 2, right? So again, that's up 2 and right 1. If you don't feel like you have the room to do that, you could have gone down 2 and left 1 to this spot, right? And then the last slope is going to be a slope of 3, and I definitely don't have room to go up 3 here, so I'm going to go down 3 and left 1 instead, so I'm pointing to that spot right there. And you'll notice that my slope of 3 is slightly steeper than my slope of 2, which is steeper than 1. So when the AP grades this, right, on the AP, you're probably getting 1 point for these 3 slopes combined, right? So 1 point for all of the 0 or vertical slopes, right? The weird slopes, right? And we didn't see any vertical ones here, but all those. And you're probably getting 1 point for all of the others, right? Meaning that this entire slope field is probably worth 2 points total, and these 3 are really important because they should be very clearly, obviously horizontal lines, right? And so that's kind of the idea. Now, you could realistically be asked to draw a slope field by hand on the AP. Again, if you're drawing a slope field by hand, it's going to be sort of like this picture or the one we just did. It's not going to be something like this, right? You might be given a slope field this complicated and asked to do something like draw a solution like I did in green or red here, but you're not going to be asked to draw a slope field that complicated by hand. This is a reasonable ask. And so let's go ahead and walk through another example. So I want you to do the same thing. Again, this is a scale of 1, right? So this is, it's hard to see, but that's a -1 and a 0 and a 1 and a 2, and the same thing here. This is a 1 and a 2. I know the numbers are a little small. So at those 12 points, you're going to go ahead and find the slope. I would suggest making a table, but you don't have to. It's up to you. I'm going to make one. You can pause me if you want to do it without me. So I'm going to list my points x, y, right? And my slope is going to be x on top of y, right? And again, if you can do this all in your head and not get it wrong, that's totally lovely. Congratulations, you're awesome. So I'm going to start here because I always start at this point and work my way up. You do not have to do what I do. It's just what I've done for years, so it's what I'm going to keep doing. So -1, 0 is the first point, -1, 1, and -1, 2, right? So those are the points I'm going to do in green. Then the next column of points is going to be 0, 0, right? Oh, and actually, interesting thing, I shouldn't have asked you for this one. So pretend I didn't ask this one. So let's call it the 11 points. The AP actually won't ask you for this one. So cross that one out, and I'll explain why in a second. 0, 1, and 0, 2. So they would say 11 points. They would not have asked you for that one, so I apologize for that. Let's see. 1, 0, 1, 1, and we're going to squeeze in 1, 2 if I can at the bottom, right? And then the last 3 points, my x comma y, my last 3 points, or my slope is x over y, are going to be 2, 0, 2, 1, and 2, 2, right? Okay, so we'll talk about why this one wouldn't have been requested in a minute. Okay, so let's start here, right? -1 on top of 0 is undefined, right? So we'll get to that in a sec. -1 over 1 is a -1. -1 over 2 is just a -1/2. In red, and again, we'll talk about this one. So the reason I can't ask you for this one is this is 0 over 0, which is called an indeterminate form. You can't graph it. So the AP won't ask you for it, and if you get 0 over 0 on a slope field, check your math because you did something wrong. So the AP is not going to ask you for that. Here, right, I get 0 over 1, which is 0, and 0 over 2, which is 0. In blue, I'm going to get 1 over 0, which is that same undefined, right? We'll talk about that in a sec. 1 over 1, which is just a 1, and 1 over 2. And then this last column, right, I get 2 over 0, which is that same undefined, right? 2 over 1, which is 2, and a 2 over 2, which is a 1. Okay, so let's go ahead and draw these slopes. All the undefined ones are vertical lines, right? That's what an undefined slope looks like. So if we erase that extra green line there for a sec. So I'm going to have a vertical line here, right? Then I'm going to have a slope of -1. Well, a slope of -1 means down 1, right 1, so it's going to go to that red point that I crossed off, right? And then a slope of -1/2 is going to go down 1, right 2, so it's going to point to here, so that's something like that, right? So that's the green slopes. Then I do the red slopes. Remember, you're not going to be asked for this spot at all, so this will not be asked, and I apologize for missing that when I wrote the problem, right? So both of these are slopes of 0. Well, 0 is a horizontal slope, right? A horizontal line. All right, so in blue, right, I have an undefined. Then I have a slope of +1. Well, that's going to be up 1, right 1, so that's going to point here. And a slope of +1/2, which would be up 1, right 2. But if you feel like you don't have room for doing that, go down 1 and left 2. I'm going to point to that spot right there. Okay, and then lastly, the colors that I did in black here, right? So the slope 2 over 0 is undefined, right? 2 over 1 is a slope of 2, so that's up 2 and right 1. Again, if you don't feel like you have room for that, you go down 2 and left 1. You're going to point to this spot. That's a slope of 2, right? And then the last one's a slope of 1, so that's up 1 and right 1, but again, if you don't have room for that, you could go down 1, left 1, point to here, and there's your slope of 1. So again, if the AP were scoring this, you'd be getting 1 point total for all of the weird slopes, right? So all of the weird slopes, so the horizontal and the vertical slopes total are worth 1 point, right? And then all of the other slopes, right? So the horizontal, so by this I mean horizontal, right? And by this I mean vertical, right? They're worth 1 point total, right? And then all of the other ones, right? So all of the others, so all others are worth 1 point. So generally, AP problems give you 2 points for slope fields, and that's usually how they score them. But it means you want to be really, really cautious about those horizontal and vertical slopes. So you're not going to be asked for this point, despite the fact that I accidentally asked you for it in the first place. All right, moving on. Okay, so we're going to draw a slope field for the given differential equation, and we're going to fill the axes. Now, you might say, but Hogan, you just told me that if we're doing it by hand, you're not going to give us a ton of points. You're going to do something like this. In fact, Hogan, you specifically said that we wouldn't be asked to do something like this unless we were doing it on a calculator, and now you're doing it. Well, that's because this is kind of a trick question. So when we look at this, what I want you to notice is that when a slope field only depends on one variable, it's much easier to fill out the slope field. Because see how this only depends on x, right? So while it might look like I'm asking you to plug in a bunch of numbers, I'm not. You might say to me, but Hogan, look, there are 10 points going in this direction and there's 10 in this direction. You're asking me to plug in 100 points. I'm not. I'm actually asking you to plug in 10 things. Because what I want you to notice is that for all x equals, let's say, -5, right, dy dx evaluated when x is -5 is going to be a -10, right? So this entire window, right, over here is going to have a slope of -10. Now we're going to deal with that in a sec. Let me clean up my notation a little bit. So I'm basically just plugging in strictly the x values. So dy dx evaluated when x is -5, since y is not in any way involved in this expression, is going to be -10. And dy dx evaluated when x is -4 is a -8, right? And dy dx evaluated when x is a -3 is a -6, and dy dx evaluated when x is a -2 is a -4. And so I think we're getting the gist, right? dy dx evaluated when x is a -1 is a -2, and then we can see that dy dx, when I evaluate that at x is 0, is just a 0. And I'm going to get the same slopes on the other side, just positive, right? On the other side, I'm going to get a 10 and an 8 and a 6 and a 4 and a 2, and then there's the 0, and there's my -2 and my -4. So I can see the trend. So while it seems like I'm plugging in a bunch of stuff, I'm not really, right? So those are my slopes. So now I just have to draw them in a slope field. So let's start with the obvious one. Let's start with the 0. Everywhere on this axis where x is 0, I'm going to have horizontal lines. Right? Everywhere here I'm going to have horizontal lines. Okay? Then all I need to do is draw one single slope of 2 and then just copy it. So right here I should go up to right 1. This is a slope of 2. Great, we're just going to copy it. Doesn't have to be perfect, right? Just has to be kind of close. Okay, so just there's my slope of 2, right? And actually I can make the argument that on the other side I can do -2 at the same time because it's exactly the same thing, right? -2 is the same thing but in the opposite direction. So from here I'd be drawing down to this point. Okay, that looks like that. Great, let's draw all of our slopes of -2. Right, and yes, this is still tedious despite the fact that it's not as tedious as you might have thought it was when I asked you to open, or when I asked you to start doing this, but you get the idea. Then I need a slope of 4, right? I just have to draw one slope of 4. So starting here, I'm going to go up 4, right 1. So I need to go all the way up here. Well, that's pretty steep, and I'm just going to copy that here, right? And I can do the same thing on the other side, right? So here I want a -4, so I'm pointing here. Well, that's going to look like this, and I'm just going to copy it, right? A bunch of those. And you get the gist. The other thing to keep in mind is that really it's about the slopes being comparatively correct. So your slope of 6 and your slope of 8 and your slope of 10 are going to start to look pretty similar. They're just, by the time you get to 10, they're basically going to look like a vertical line, right? So a slope of 6, if I start here, is up 6, right 1, so that's pretty steep. That's going to look sort of like this. See how that's a little bit steeper than 4, right? It's not a vertical line yet, but it's getting steeper and steeper and steeper and steeper, right? At 8, if I start here, is going to start here, and go up 8. Well, that's really pretty steep, right? And then by the time I get to 10, I'm basically drawing vertical lines. So within reason, you don't have to obsess too much about this. So 10 means I'm starting here and I'm going up 10 and right one. Well, that's here. Yeah, that's pretty darn close to a vertical line, right? So see how that's steeper, but it's still not vertical, but it's steeper than 8, right? And so that's the idea, and it doesn't have to be perfect. And we do the same thing on the other side, right? So here it was supposed to be 6, right? So if I start here, I'd be pointing down at this point 6 units below. So I can do this and kind of figure out that 6 is a little steeper than 4, right? And you're really not likely to be asked to do this on an AP, but I wanted to show you that if I do ask you to do this, it's because it's not actually as difficult as you're thinking it is. It's not about plugging in all of those points. And yeah, it's still tedious, but that's okay. All right, so we finish this out. There's my 8s, right? They're negative. And then my negative 10, again, I'm kind of going up to here and pointing all the way up there. So it's a little steeper than 8. You do the best you can to make it get steeper as you go. And that's fine, right? So you're going to give one of those a try. Again, same idea, right? You're drawing a slope field, but because it only depends on y, you're not actually finding 100 different points. You're finding the 10 different y values, right? So actually 11 if you count 0, but you get the idea. So dy dx, right, evaluated when y is negative 5, is going to be negative 6. And dy dx, evaluated when y is a negative 4, is a negative 5, right? dy dx, evaluated when y is a negative 3, is a negative 4. dy dx, evaluated when y is a negative 2, is a negative 3. My dy dx, evaluated when y is a negative 1, is a negative 2. dy dx, evaluated when y is a 0, is a negative 1. dy dx, evaluated when y is 1, is 1 minus 1, which is 0, right? So that's going to be the big important one, right? dy dx, evaluated when y is 2, should be a 1. dy dx, evaluated when y is 3, should be a 2. We're almost there. dy dx, evaluated when y is 4, should be a 3. And finally, dy dx, evaluated when y is 5, should be a 4. Now, you might not have needed to write all these, right? You might have logically been able to say, hey, I get the pattern. So I'm going to go ahead and start at y is 1. At y is 1, the slopes should all be 0. So all along here, anywhere that y is 1, the slopes are 0, right? So then I'm going to start with the ones that are a little bit easier, right? So at y is 2, my slope should be a positive 1. So at 2, I should be going up 1, right 1, meaning the slope looks like this. Well, that means all of the places where y is 2, the slope looks like this, right? And they should all be about the same. When y is 3, my slope is a 2. So up here at 3, I should go up 2, right 1. So that's a little bit steeper, right? It's not super steep, but it's a little bit steeper than the last one, right? And again, it's mostly comparative. Nobody's actually sitting and counting. They should be close, but it's not a big deal. At 4, my slope should be 3. So I can either go up 1, 2, 3, and right 1, which is totally fine. And that'll be a little bit steeper than 2, right? Or you could have gone down 3 and left 1, and that would have been fine, right? And then at 5, my slope should be 4. So here I can either go up 1, 2, 3, 4, and right 1, which is fine. I can aim for that spot right there. It's a little bit steeper than the last round of slopes, right? Or I could have gone down 4 and left 1, and that would also be fine. So these are my little snippets of slope, right? You're much more likely to be asked to match these than you are to be asked to draw them from hand when it's this big of a slope field. So I did all those. Let's do the negative slopes in red. So at y equals 0, all my slopes should be negative 1. So that means down 1 and right 1. So they're going to look like this, right? I'm just going to draw all these little snippets of slope, right? Again, I know you're probably already fast forwarding and have decided that you're over this video, and that's fine. I get that this is tedious, but you should know how to do it at least. So negative 2 slope would be down 2, right 1, so that's going to go right to this point here, right? Then I'm just going to connect all the dots and make them all work the same way, right? I'm going to draw the same line there. All right, so this is done and this is done, and then I get at negative 2, I should have a slope of negative 3. Well, that's down 3, right 1, so I'm aiming for this spot right here, and then I just do the same basic slope over and over again. And it doesn't have to be perfect. I get that some of mine aren't as good as others, and that's okay, right? We get the basic gist of it. All right, and then I have a slope of negative 4, right? So that's going to be, now I'm running out of space to go down for 1, 2, 3, 4. I can kind of make that work, right? And again, it's just slightly more negative than the last slope, right? And you could probably at this point cheat a little bit and say, cool, I'm just going to slowly make these slightly steeper negative, and that's fine, right? You could probably say, hey, I'm going to cheat and make this just a little bit steeper, right? A little bit steeper than the last one. And then make this one even steeper, right? And that's fine. They shouldn't actually hit vertical, but it's okay if you're sort of cheating a little bit at the end to get there. All right, so those are my slope fields. Let's keep moving. All right, so sometimes instead of being asked to draw a slope field, you're going to be asked to match a slope field to a given differential equation or vice versa. So this is much more likely to be what's going to happen in this situation, is that you'll be given this picture and you'll have to match it to this differential equation. It's unlikely you're going to be asked to draw something this big by hand, but it's possible, right? So when you're presented with this task, there is no one right method for deducing the correct answer, but there are some logical hints, and these are not in any particular order. They're just skills that I have found useful in the past, and we're going to walk through several examples with them now. So does the slope field only depend on one variable? Now we saw that in both of the last examples, right? So if the slope field only depends on one variable, what that's going to mean is all of these slopes in a single vertical line are the same. And see, that keeps happening. All the slopes in a single vertical line are the same. Well, that means that it only depends on x. If you have all the slopes in a single horizontal line, only depending, like they're all the same in one horizontal line and they're all the same in every horizontal line, well then that means it only depends on y. That can help you pick an equation that only depends on x or only depends on y. Another possible hint is, where are the weird slopes? So if we go back up here, notice that wherever wherever y equals 0, there was a vertical line. Well, that tells me that y is probably in the denominator, because whenever y is 0, I suddenly get something that's undefined, right? Similarly, whenever x was 0, which is on the y-axis, I get a flat line. Well, that probably means there's an x in the numerator, right? So look for the weird slopes. That's a really good hint. Last thing, if the diffie-q is all multiplication or division, then what you'll notice is that the signs of the quadrants matter. So for instance, if I have x times y, well, quadrant 1 should have positive slopes, right? Because positive times positive should get me a positive slope. Quadrant 2 should have a negative slope, because a negative times a positive should give me a negative slope. And so I can start to match and look at the different options in the quadrants and see what happens and which ones fit. So usually these hints are enough to narrow down the choices to the correct slope field or function. However, if you've done all of this and you're still stuck between two choices, you might have to be a little more creative and just straight up plug in some points on the slope field and see if they give you a slope that's approximately right. That's usually my last plan, but it is something that you should consider as an option. So let's go ahead and walk through some practice. So we're going to match each slope field to the differential equation. So when we look at this, first thing I'm going to look at, right? So I look at this one and I notice that a few things are true here. Okay, I notice that in a horizontal line, all of the slopes in a horizontal line are the same. So this tells me that this is a graph that only uses y. Well, I look at the choices and I see that there's only one choice that only uses y. It's this one, right? So I say, wait a second, this one only uses y, right? So this one must be A. I can also confirm that that's true, because if I plug in y equals 2, right? So if I wanted to check this, right, when y equals 2, 2 minus y equals 0, right? And that's what I want. I want 0 slopes at what seems to be y equals 2. So that one seems to be A. When I look at these other options, right, so when I look at, let's say I look at this one, right, let's say I look at this one right here, right, this one, all of the lines in a vertical column are the same slopes, right, all the same, and here's the ones that happen to be 0, right, but they're all the same. So this seems to be x only. So right away, as soon as I know it's x only, I know that it's either the top one or it's the bottom one, right? Well, I look and see that this one, right? So I look and see that it's either, so this one is either, this one's either dy dx is sine x, or dy dx is x, right? But I look down at C and see that C is in the same situation where each column, right, each column is the same. So this is also an x only graph. So basically these two are those two patterns, right? So remember that one thing you can do is you can look and see what would happen if you drop a leaf into the pattern, right? So let's say I drop a leaf in right here and trace what would happen. Well, if I drop a leaf in here, I seem to get something that looks like an x squared. It would fit that the derivative of an x squared is x, right? That looks like an x squared. That looks like a parabola. So this one's probably B. When I get to this one, if I drop a leaf in, right, it's going to go up a little, and then it seems to level off and come down a little, and then come up a little. And if I go this way, it seems to go up, and then down, and then up. Oh yeah, that's definitely trig, right? That's definitely trig. It fits that that could be a sine or a cosine function. So that one definitely is C. And that leaves us only with the last option, D, but let's walk through it anyway. If I were trying to figure out D, I would look at this line, and I would say, oh, that's weird. On the line y equals x, I seem to have a slope that is 0, right? So that seems to be the line, like 1, 1, 2, 2, and so on and so on. Well, that fits, because if my slope was x minus y, and my slope is 0, well, that's when y equals x, right? So that's my answer, D. So mostly I'm just matching and trying to cross off answers. Now it's a little more complicated when we're not matching, or when we're only given one slope field and we have to match it to a particular equation. We're going to do that again when we get to example 4, okay? So let's go ahead and do P3. So give this a try. I want you to try and match the differential equation. So each one of these matches one of these values, right? I'm going to go ahead and walk through as well. So couple things to notice, right? So first thing I notice is that this one, right, see how these horizontal lines going across all have the same slope? That tells me that this one is y only. So I look at my choices and say, well, which ones are y only? Oh, hey, it's this one. This is C, right? Because this one's x only, right? This one's x and y, and this one's also x and y. By the same argument, I look to see which ones have the same slopes all the time going up and down. Well, this always has the same slope. Every column up and down is the same slope, which means that this must involve x only. Okay, cool, that's B. So now we come down to the two that both involve x and y. So if I want where this function is 0, right? So if I want where x plus y is 0, x plus y equals 0 whenever y equals negative x. Well, that's this line, right? That's this line. So this slope field, right, or this differential equation should have a slope field that has 0 slopes along this diagonal. That's this one, right? That's definitely A. So that leaves me with the only option being that negative x over y is D, but let's actually walk through it, right? So let's confirm this makes sense, right? When x equals 0, I should have a horizontal slope. Well, sure enough, that checks out. X equals 0, horizontal slope, check. When y equals 0, I should have a vertical slope. Well, you can't see it on here, but sometimes no slope at all is the same as vertical, so yep, that checks out, that's fine. Other things that check out about this, that trick that I mentioned about the signs, right? So this is negative x over y. Well, what that means in quadrant 1, where I have positive comma positive, the slope should be a negative in front of a positive over a positive. The slope should all be negative, and sure enough, they are. In quadrant 4, where I have a positive x and a negative y, the slope should come out positive, and they do because I have a negative in front of a positive over a negative. That comes out positive, and sure enough, all those slopes are positive. So this one's D, and again, some of that becomes process of elimination, right? But a lot of this is about eliminating possible choices. So let's go ahead and do 2 more examples. This time you'll only be given one slope field, and you're going to have to match it to a differential equation. All right, so which of these differential equations could match this slope field? So let's look at what's going on here. So the first thing I notice is that when I go across horizontally, they're all the same. And I check that that's true all the time. But look, if I go across horizontally at 2.5, same slope. So once I realize that, that means that this graph is depending on y only, right? Because all the slopes going across horizontally are the same. So I can cross off A and I can cross off C. I now know that I'm either looking at B or D. So now we can logically look at the options, right? So I know that if so I look at this graph and I see there's these little horizontal lines right here, right? Well, actually, there's a couple options. I can either look for where this graph has zeros, and it is hard to see, but there are horizontal lines on this x-axis. But the other really logical thing to do is look and see what kind of slopes I have. If you look at this picture, see how all of these slopes are positive, right? So these are all positive slopes. except right here where the slopes are 0. So at y equals 0, the slope seems to be 0. So if you look at this answer, this won't be all positive slopes because there's a negative in front of a 1 over y. Well, if y is a positive number, this would be a negative in front of a positive. So this is not all positive slopes. Can't be the answer. My answer has to be D, right? The other logical way to see that is that there are 0 slopes right here, but I think those were a little bit hard to see on the diagram. All right, so let's try one last problem. I want you to match the differential equation to this particular slope field. So figure out which one matches. Pause me if you want to do it by yourself. All right, so the first thing I notice is that going all the way across horizontally, it's not the same slopes. So it's not y only. So I can cross off anything that's y only, but none of them are. I look vertically and see that not all of the slopes vertically are the same, so it's not x only. But I look at the answers and none of them have x only. So neither of those were helpful information, but it's true. So now, the next logical thing to do is look at the weird slopes, right? So I look for where the weird things are happening. And where it looks to me like the 0 slopes are happening seem to be right here, right? That's the 0 slopes. So once I know that, this is probably the line y equals x, right? So the 0 slopes seem to be that line where y equals x. Meaning, if x and y are the same, I should get a 0. One really easy option is to pick an easy point. Pick the point 1, 1, right? So you can even just look at all these options and pick 1, 1 and see what happens and if you get a 0 when you plug them in. So you know that your dy dx, if you plug in 1, 1, should give you a 0. Just check. 1 plus 1 is not 0. 1 minus 1 is 0, so that's a contender. 1 times 1 is not 0, so not it, right? And negative 1 times 1 is not 0, so not it. Hey, look, your answer's B. If you'd gotten multiple answers that gave you the right slope at 1, 1, then you might want to look at some other points. But that's basically the gist of how you match a slope field, and that is our 7.3 video.